Hi. I'm Eri Rubin. I'm one of the founders of DeepCube, and today I'm the VP of AI at Nano Dimension. So we all know that AI is the next big thing. Everybody has to adopt it in order to stay relevant. And actually, we've heard today quite a lot about what AI is, what is this AI revolution, and some pretty good talks explaining the history of AI. So I don't need to go over that again, but AI is a very, very broad field in computer science. And it's mostly been stuck for many, many years. When I started university, quite a long while ago, I was fascinated by AI. I went into the AI lab and was very, very disappointed. I saw a bunch of researchers there working on very minuscule problems with very, very limited success. I actually went on a different path and came back to AI quite a few years later. So all of these classical AI approaches don't really work in the real world. And then we have machine learning. Machine learning has shown finally something that can really work and change things in real world scenarios, but again, to a limited extent. And the last major breakthrough in machine learning has been in around the early 90s. So what is happening? Why didn't we start hearing about the AI revolution 30 years ago and just now? And here comes a term that has been thrown around here called deep learning or artificial neural networks. And this is the real, I refute the analogy before. This is the real engine behind the AI revolution, because this technology has enabled us to vastly increase and change, do things that were previously, by me and my colleagues, thought to be impossible for anywhere in the near future. And what we're doing right now is taking this technology and applying it to industrial manufacturing in general and digital printing today. So what is the difference between deep learning and any other classical algorithm approach? So one of the main problems in algorithms, for example, facial recognition. So we have an image of a face and we want to identify the person. Well, with classical algorithms, we can't just throw that image into the algorithm. It needs to be pre-processed. We need a domain expert that will come and create and extract the key features, the key parameters that are needed to do this task. And then the algorithm takes this vector of features, vector of numbers, and does the actual analysis. There are two major problems with that. The first one is that we're throwing a lot of the data out. We're taking an image of millions of pixels and reducing it to a small set of numbers. The second, much more profound but less intuitive, is that we as humans are quite bad at defining these features that are important for this task. And just to give you a hint of how bad we are at this, we like to give a small exercise. So if I give you an image of a dog or a cat, you can easily classify if it's a dog or a cat. You know, the images that Tom said, you all saw, it was clearly a dog. Nobody confused it with a cat. Yet if I asked you to give me, as world-renowned classification experts between cat and dogs, what are the key features that help you do this task? If you think about it a bit, you'll see that it's very hard. Now, I won't waste your time today and do this exercise with you, but I've done it many, many times. And people talk about the size of the cat, and you see that you have small dogs, you have big cats, you have different furs. It's very, very hard to define it. And yet it's a very, very easy task. After a few minutes of discussion, sometimes somebody comes up with the one real magical feature, which is the pupils. Dogs have round pupils, and cats have ovals. But then you have this problem. And what does this have to do with industrial processes and digital printing? Well, as I've been said before, we are drowning in data today. Okay? Digital processes and manufacturing processes have vast amounts of data, different types of data coming from inside the machine, from sensors, from outside sensors, from environmental raw materials, and it's a big mess. Pretty much an impossible task for even the best domain experts to come, take all this data and try to find the correlations and explainability out of it. And that's where deep learning has this amazing ability of automatically finding the correlations between the data and the things that interest us. And it does automatically find the features that are needed for the task that it's doing. So for the real AI revolution has started around 2012, 2014, and you can see that mainly in academia. So these three fields in academia have been completely demolished and changed. Okay? For the past 10 years, there have been practically no papers written in any of the other classical approaches because deep learning, deep learning blows those results out of the water. It has improved by 20 to 30% the state-of-the-art results in all of these three domains. And in the industry, you know, we've been hearing about Industry 4.0 for a very long time. You know, smart, connected factories, connected manufacturing. But the adoption has been slow, and the benefits are questionable. And today we're heading into Industry 5.0, where we are actually using AI to the items that were already talked about before to create a real AI engine that is connected to the machine and transforming it into a real smart system in real time. So data collection in itself has no real value. And even if you collect the data and you start to analyze it, then you can get limited value out of it. And the only real way to gain significant and meaningful value from all this effort of collecting the data and connecting the machines is if you have a real-time AI engine that is sitting on the machine, getting the real-time data and turning it into actionable insights. And that is what we have been doing in DeepCube. So in DeepCube, we have quite a large team of around 30 people, all dedicated to AI for industrial applications, and specifically for industrial manufacturing machines. We have quite a large team of deep learning experts, data scientists, sometimes they're called. And we also, on top of that, we have a large team of data engineers and data analysts. Because we have such vast amounts of data, we need a special team just to handle and prepare this data for the deep learning part. Another big hurdle that has not been talked about so far is the deployment of these AI solutions. They usually require vast amounts of compute power. And for that, we have a dedicated team of software engineers who are specialized in building the platform and deploying these AI solutions, this AI engine, efficiently. And what we're doing now is working with our friends in GIS and trying to address the pain points in digital printing, which are, I don't need to tell you this, but maintaining high quality in longer and longer runs. As people said here before, the loss of domain experts who've suddenly decided that they want to do something else after COVID, or they're just a dying breed. And with AI, with these AI engines, you can reduce these pains and improve your performance, your digital printing performance. So one of the things that we know, it's pretty common knowledge, AI is not an off-the-shelf solution for the most part. And the way that we approach it is we work with our customers / partners together, taking their domain expertise and our AI capabilities and tailoring a solution for their specific needs. And we've done a bunch of very successful projects with industries, as you can see. We split our products into 2 categories. So the first is production health. That is looking at the production process itself in the machine state, where we learn how the machine is supposed to behave, how it behaves normally, and then when it starts to deviate from this behavior, then we can alert the machine operator, the engineer, whoever needs to know about it, and point him to the specific area where he needs to address it. The second product has to do with QA, and that is where you have a more sophisticated system, when you have a system that produces the quality assessment features. At the end, you can use this data to feed back into the AI engine, and then the AI engine can predict the quality of the output just from the sensor readings in the machine. Okay, and increase the quality, reduce waste, and also reduce the amount of dependency on very expensive QA many times. Now, the AI engine that we're talking about needs to take in all these different data inputs in order to produce these outputs. So this is a very complicated task, and AI is a rather new field, and not many people know how to build this AI engine correctly, which is one of the reasons that it's taking long and there are a lot of failures in this area. So this is a use case that we've done. Nano Dimension, our parent company, has different divisions. Some of them manufacture 3D printers that use digital printing for the base of the platform. And we have done a very successful project with the printers that actually print electronics. We've done a real-time error detection system that can identify when the print is starting to have defects in it before the defects become critical, and then in a closed loop fix the printing issue so that the final product is still okay. And we've also worked with them to integrate our solutions for print setup to monitor, the print head status and all of that for calibration before the print starts. Now I'll hand it over to Simon, my colleague, to continue.
So we do all sorts of stuff in digital print. So as Eri was saying, we're talking about printed electronics. We're talking about printing direct to shapes. We're talking about printing onto very complex surfaces and printing colour or adhesives or varnishes or anything that an inkjet head can print. It could be a DNA sample. It could be some sort of unusual thing entirely. So digital print is very vast, but digital print for us comes down to one thing. It's an inkjet head. It's an inkjet printing head. And we're trying to get very small drops of stuff out of a head. And invariably, we're pushing the envelope of these things. So we're seeing applications which are becoming more demanding than possibly what the print heads can actually drive. That in itself means we need to have intelligence. And for me, that's what this is all about for AI and intelligent technologies around inkjet printing, is how do we get to the extreme cases that people want to achieve when perhaps the product or the objects that are driving them aren't quite there yet. And it's kind of like, as I say, it's like flying a space shuttle. It doesn't really fly itself very well without a supercomputer behind it. It'll probably just fall out of the sky. So this is where we're looking at how AI can benefit us. So if we have a look, for example, in particular in industrial digital printing, one of the biggest challenges is print quality. How do we get the best print quality out of these things, and how do we do that in a way which is actually clever and smart? I've spent my whole life, or most of my life, a good part of it, looking at prints. Looking at prints from machines and trying to work out what is happening. Where is the print problem? Is it because there's a device on the printing machine that's not doing what it should do, or is it in the right place, an encoder, for example? Is it in fact an artifact because of the way the print head geometry is, the nozzle geometry? Is it because the ink is getting starved in the print head? What is actually causing it? There's a myriad of things. I've become relatively good at it. I've had some interesting discussions with Guy here about the industry and where we're going and the lack of, or the depletion of knowledge around these sorts of things. So it is quite a complex thing. AI offers the opportunity, hopefully, to remedy some of that because the complexity is increasing, but the knowledge base and the number of people in our industry isn't necessarily. And I think that's quite important. Traditionally, this is a sort of a classic example of optimization. Most of you in the room know these things in terms of linearization, color management, color profiling, fixing broken or misdirected nozzles in a print, density defects because print heads don't all work the same and nozzles don't work all the same, and different ink sets and ink pressures and all sorts of things. However, at the end of the day, most of this is done by printing a test pattern. So you print a test pattern to do a color correction, you print a test pattern to look where you've got missing nozzles or misdirected nozzles, etc., etc. You print a pattern. However, when you print 10 kilometers of substrate, which is where the industry is going, you can't print a test pattern in 10 kilometers of substrate. You could, but the downstream impact is high. I print 10 kilometers, I get a defect. If I don't know where it is, even if I get a defect and I can detect it quickly, what will happen is I'll have to stop and do something about it. I'll have to splice it, cut it, move it around, re-roll it, etc., etc. Also, by the way, by the time I've detected it, quite a lot of substrate's gone through. You know, most printing presses running at 800 meters a minute, digital printing presses getting up about 300 meters a minute. Fractions of a second, substrate's gone. Eri made a very valid point, and that is what AI can offer us is actually see it coming. In other words, using that sort of technology, perhaps we'll be able to see the quality or things going on before that happens, where, in other words, before it hits the point where it's a problem, that we have to take it out and not use those printing and detect it beforehand. And that's what it's all about for us. It's about how can we early predict things are going in the wrong direction and do something about it before the problem occurs and then remedy it. So this is also a classic kind of closed loop compensation. Again, I've talked about this in a lot of presentations in the past, but the general idea is you start with a workflow at the front end. Somewhere down the back end, you've got some inspection systems. So you have things that can detect things, you have things that can measure things, lots of great data. You need to do something about it. Again, most of this works really well for test patterns, but what happens when you don't have a test pattern? You need to do something. So the ultimate objective that we have as a team is to how can we actually deliver to the industry really meaningful AI technologies, which actually leverage a whole range of things. There's a lot of inputs. There's pressure sensors, there's vibration sensors, there's all sorts of things and data that we can get from printing machines that we can correlate or use as inputs along with image data. So of course the main objective is how do we just take print data while using printed images along with everything else and from an AI perspective, be able to say, we believe these things are going wrong, this is where the issue is, and feed forward. So what you want to do is feed forward that result and do something about it. What that will allow us to do in the future is to be able to decide where to put things as well. So in other words, we've got a range of printing presses in a factory. There might be all sorts of different types and styles. We'll have a print job coming in. We'll be able to do a couple of things. One is you'll be able to determine which printing press to put it onto based on its current quality and performance, or the predicted performance, for example. So taking predicted data, which might say, oh, this printing machine number 1 is likely in the next 3 hours that it's going to need to have a print head changed or a filter and an ink system changed. Use print number 2 because your print run's going to be 4 hours long. So you'll be able to distribute those things based on that. Then you'll be able to look at those machines from the predictive models, then do something about it in advance, and hopefully massively optimize the whole performance of the printing operations on a job-by-job basis. We recently announced our Atlas Ready program. Many of you probably saw it. Some of you probably thought, what on earth is that about? We also recently announced a partnership with IST Intech. I think Simon Roberts, are you here? Yep, he's up there, so you can have a chat with him later. And you probably thought, exactly what is that about? So to put it into context, what we're looking at doing is building into our technology and products the ability to take all the information from a printing press, bring it into the DeepCube type learning models and machine learning and AI, understand predictably what's going on from image-based data and sensors, and feed it forward and improve the print quality, all the quality in all sorts of ways. To do that, of course, we need to develop partnerships, and IST is a classic example of that partnership. So what we're looking to do there is to coordinate their devices with our products to be able to understand what's going on, manage it from an image-aware perspective, so we know what the image data looks like, we can manage what's going on, both how much energy we use, how we drive the printing press, but also how do we extract the data from that in a meaningful way that we can see what's going on. So if we can see something in an image data, with all the sensor data we've got being collated into one thing, then we can push back and see. Now, one of the slides that I think Nathan probably picked up on, that, and Nalima who are here, Eri had a slide. Actually, the slide was a whole lot of text in black and white with things all over it. That text is actually the event feed from our Atlas Ready product. So that event feed provides all the events that are going on in a machine, all collated, pushed up into a learning model, and the future for us is to take that, look at predictive modelling on it, understand what's happening going on, do something about it, resolve those issues, increase the print quality, but not just that, also optimise everything so that we get the best we possibly can out of digital printing technologies going forward. And that's for us is where we're going. That is the whole objective. I'm going to finish there because I know we're now up to coffee time. But just this is sort of a quick summary of the Nano Dimensions objectives around the strategy about having tailored solutions for AI. And again, to what Eri was saying, having one thing that fits all, you won't find. You won't be able to go and buy off the shelf a bit of software and just go and pop it in. You might eventually in 5 to 10 years' time, but currently you need to look at each situation. You need a team of people that can wrap themselves around a problem, solve the problem, and deploy something which, of course, is autonomous after that. And that's what we're offering to the industry, is a team of people that can solve problems, engineer the solutions, put those solutions in place and make a real difference. So thank you very much. I'm going to finish it there. And again, also thanks to the FuturePrint team for doing AI print, because I think it's the right timing. And if you've got any questions, by all means, during the coffee break, come and ask us.